Lesson 1-3 is measuring segments. So there's this postulate, it's called the Ruler Postulate. I will never ask you to tell me the Ruler Postulate, but just so you understand what's going on here, the Ruler Postulate says if you have a segment where this is A and this is B, so this has a value of A, so say it's at -2, for instance, right? That's your A value. We're not going to actually give it a value. And then this is at B, so maybe it's at 7 or maybe it's at 13, okay? So A and B, the lowercase, are your values where they are on the number line. A and B are your placeholders for what point we're talking about, okay? If I want to know the length of AB, okay, so when we talk about the length of AB, all you have to write for that is AB, okay? If we don't put the segment over top, we're talking about how long it is. So if I just say AB equals, the way you figure it out is you subtract A and B, and you take the absolute value. Anyone know why you would have to take an absolute value for that?
Because going forwards and backwards, like if you go backwards on the number line, is still a positive number.
It's still a distance, right? It's still how far did you go? And then there might be negatives involved, and we don't want negative distance. We want to know it was 6 units away, even if we went 6 units to the left, okay? So if you subtract A minus B and take the absolute value, that's how long that segment will always be, okay? That's the Ruler Postulate. So like this first example here, let's say I give you a number line. We're just going to put a whole lot of points on here. Okay, and we're going to start at -4 with point S. And then it would be, we're counting by 2's here, -2, 0, 2, 4, 6, 8, 10, so on and so forth. We're going to stop there. So if I give you point S is at -4, and then I tell you point T is at 6, and I say, what is the length of ST? What are you doing? Yeah, Daniel.
-4 minus 6 in the absolute value.
Right. Okay, now here's the thing. Because you're taking the absolute value, it does not matter which order you subtract in. So I can do either -4 minus 6 and take the absolute value, or I can take the absolute value of -6 minus 4, and I would get the same thing. Okay, so it doesn't matter the order you go in, just subtract the two numbers. So -4 minus 6 is -10, but we are taking the absolute value of that. So the length of ST is 10 units. So that segment is 10 units long, okay? -6 minus 4, again, -10, still 10 units. So like I said, doesn't matter the order you do it in, ST has a length of 10. Okay, subtract them, take the absolute value. Questions on that? Okay, you won't do a ton with that where you just have to find the length, but what it brings us to is a postulate that you will see a lot. It's called the segment addition postulate. And I bet if you stop and think about this one, you can tell me what the postulate says. So I'm going to give you a picture and see if you can come up with what you think it says. Okay, so here's point A, point B, and point C. I would like an equation that relates segment AB and segment BC to segment AC. Could you give me an equation that compares those three segments? Right. Okay, so segment addition postulate says the two parts equal the whole thing, right? So segment AB, or the length of AB, we're going to say, we're not going to make it a segment right now. The length of AB plus the length of BC will always equal the length of AC, right? So if I take this piece AB and add it to BC, it's going to equal all of it, okay? Which is something you know already. It's just you've always done it with expressions, not with segments, okay? So it's information that should not be terribly new to you, but now we're going to do it with these segments instead of just an expression. So let me give you an example of how you would use the segment addition postulate, and then I think it'll make a lot of sense if it's not making sense yet. Here's what it says. If EG is 59, what are EF and FG? And here's your picture. Here's E, here's F, here's G. EF is 8x minus 14. FG is 4x plus 1. I'll give you a second to finish drawing that. Solve the problem. If you think you know how to solve the problem, you're welcome to try on your own right now. Okay, so here's the scoop. We are given enough information to figure out what x is. Anyone see how we could solve for x? What's the length of EG? 59, okay? And that's something that a lot of people just like forget to pay attention to, is in the directions they gave you a crucial piece of information, right? EG is 59. So if I know EG, I know this length is 59, and I know the two parts in expression form, I can solve for x by adding those two together and setting it equal to the whole thing, okay? So what you're gonna do is take 8x minus 14, add 4x plus 1 to it, and set that equal to 59. Do you see that? So that's your two parts added together, set equal to the whole thing. You don't need parentheses, but I'm just trying to show you where we're getting our pieces from. Okay, so now from there, algebra. And I know this class said a lot more people liked algebra, right? Or were we were kind of 50-50 in this class. But here comes the algebra. So we're going to do 8x plus 4x. So that's 12x. Be careful with your algebra here, right? This is a negative 14 plus 1. So that's negative 13. So 12x minus 13 equals 59. What do I do next? Just tell me. Add 13 to both sides. Ah, the algebra. Did you miss it? 12x, this is gone. So you get 12x equals 72, and then divide by 12, and x is 6. Okay? Are we done?
No.
No, what did they ask for? The lengths of the segments, right? EF and FG is what we're looking for. So what do we have to do? Plug it back in, right? Take that 6, put it here, and then you'll get what they asked you for. So EF is 8 times 6 minus 14. How's your mental math after a summer away from math? What's 8 times 6?
48.
48 minus 14 is 34. Okay, so EF is 34. FG, you're doing 4 times 6, 4 times x plus 1. 4 times 6 is plus 1, 25. So FG is 25. Do you see a good way to check your answer? Yeah, without even technically plugging it in. Take those two, add them together. Do you get the 59 that they gave you initially? And you do, so we know we got it right. Okay? Questions on that? That is segment addition postulate. All right. Let's say we have this. And if you feel like you got this already, this is the same type of problem. So you don't need to write the whole thing down again. If you feel like you got that first one, that's totally fine. But I'm going to have you talk through this one with a neighbor to see how you're doing. All right, so let's say this is the information we know. JL is 120, JK is 4x plus 6, and KL is 7x plus 15, okay? Tell your neighbor or someone around you, I don't care who, you may be in a little group of 3, but tell someone around you what you would do to solve this. All right, what'd you do? Math, yes. What kind of math? What did it look like? Yes, Raven.
You do 4x plus 6 and then plus parentheses 7x plus 15 equals 120, and then you do algebra from then to
Right.
get the x and plug it in for the x's, and then
Beautiful. Right, so we're going to go 4x plus 6 plus 7x plus 15 equals 120. Do the algebra, solve for x. Once you know what x is, did anyone solve for x? What was it? 9? Okay, so if you got 9 for x, then it's 4 times 9 plus 6 up here, 7 times 9 plus 15 up here, and that would give you the lengths of JK and KL. Okay? Any questions on that? I'm not going to finish that right now just because we did one of them already, but if you have questions, ask me later. I will walk you through. Okay? Okay, can anyone tell me what congruent means in math or just in general? Have you heard the word congruent before? Equal. Yeah, totally. Congruent, or the symbol for congruent, is an equal sign with the little tilde over top, okay? So when we talk about congruent segments, basically what we're saying is if AB is equal to BC, then AB is congruent to BC. So the length of AB equals the length of BC. So if AB equals BC, then we would say segment AB is congruent to segment BC. So basically we're saying the lengths of the same segments are the same, okay? This is length. Now we're talking about naming the segments congruent. But it's all pretty much saying the same thing. They are equal. They're the same length. Okay? The way you mark congruence, you're going to see this a lot in geometry. Let's say we have a parallelogram. You know anything about the sides of a parallelogram? There's 4. Opposite sides are parallel. Opposite sides are also what? Equal. They're the same length, okay? So the way we mark congruence, rather than have to say this is 1 inch and this is 3 inches and then have to write in 1 inch and 3 inches again, there's kind of a shortcut for how we mark it. The way we mark it are with little hash marks. So if I want to say that BC is congruent to AD, I just put those little marks, and that tells me those are the same. Okay, so that's congruent segments. But now if I want to say that CD is the same as AB, I can't do one hash mark anymore because that would say that all of them are the same and 1 is not the same as 3, right? So to mark it congruent to another one but not to all the others, you have to change how many marks you put there. So I double mark like that. Then I'm saying AB is congruent to CD. And I'm saying BC is congruent to AD. Okay, so when you see those markings, it means they are equal in length. Questions on that? Yeah, Dan. Yes, and we will get there in a couple days. But the way you mark angles is you put like a little arc in the corner, and that shows you that those angles are congruent. Good question. But yeah, we will get there. Okay, so if I gave you a number line and said, are the segments congruent? This is like, I don't know if I wrote example 2 on our last one. Did I? I did. Okay. So third example here. Let's say we have a number line with points at -2, 0, 2, 4, 6, 8, 10. Oh, that's not a 4. This is a 4. That's a 6. That's what I get for trying to skip. Okay, so we have all these points, and at -2 is point A. At 3 is point B. At 5 is point C. And at 10 is point D. Okay? My question is, are AC and BD congruent? Okay, so if I'm asking if two segments are congruent, what am I asking you? Are they what? Are they the same? Are they equal in length? Okay. How do I figure out if they're equal in length? What did we do? The very first thing, the ruler postulate. You could count, or you could just very quickly subtract and make it even simpler. So A is at -2. So if I want to find the length of AC, I'm going to take the absolute value of their difference, right? So A is at -2. And then I'm going to subtract. C is at 5, right? Because it's between 4 and 6. So the absolute value of -2 minus 5, what is that? 7. You get the absolute value of -7, which is 7. Okay. Then for BD, we're going to take the absolute value of the difference again. Where is B? What value? B is at 3. Where's D? 10. So we're doing 3 minus 10, which would be the absolute value, again, of -7, which is 7. Okay? So the question was, are they congruent? What's the answer? Yes. Why? They're both 7 units long. Okay? As long as they're the same length, they are congruent. So your answer would be, yes, AC is congruent to BD. Okay? Questions on that? All right. One last kind of concept. I mean, it's two different things, but it's one idea, really. And then we have one last example, and we're done. Here we go. So we're going to talk about two different terms that you need to know, and you will see these fairly frequently in this class. One is knowing what a midpoint is. So a midpoint of a segment. And the other one's a segment bisector, but very similar to a midpoint of a segment. Anyone know what a midpoint is? It is what it sounds like, if that's helpful at all. Yes. The middle point, right? So if I have a segment, my midpoint on this segment would be the point where the two segments are congruent to each other. So how could I mark that? How could I mark that the left segment and the right segment are the same? With your little hash marks, right? So this congruent to that would mean that the midpoint of my segment is that point right there. Okay, so it's cutting the segment in half, essentially, the point that cuts it in half. A segment bisector is very similar, but instead of being a point, it'll be like a line or a ray or another segment that cuts it in half. So a segment bisector would be if I had something like this, and then through the middle of it, I drew a line. So those are the same. This goes through the midpoint. A segment bisector would be that line or ray or segment that cuts through it. Okay? Both of them have a midpoint. It's just that one of them, the segment bisector, is going to be more than just the point. Okay? So what we're going to do with that, it's going to look very similar to what we did in example 2, I believe it was. Yes, example 2. But you have to do it differently. So I'm going to set up a problem for you and see if you can figure out what the difference is. What do we do differently in this one? Example 4. So if I tell you Q is the midpoint of PR, and then I ask, what are PQ, QR, and PR? Okay, so what are the lengths of those three segments? And here's what we know about it. Give you a second to finish that up.